All right, everybody, so today's notes are on negative and zero exponents. For your warm-up, you got a rectangle has a side length of 8x y to the z, yz to the fifth, and a width of 2x4 y2z. They want us to find the area of the rectangle. So even though this has exponents, I still need to find my area. How do you find the area of a rectangle? Area equals length times width. So I'm going to take my length of 8x, y, z to the fifth and multiply it by 2x, 4, y, 2, z. My coefficients, 8 times 2, I multiply those. My x's, I add them up to get x1 plus x4, which is x5. y1 plus y2 is y3. z5 plus z1 is z6. And that would be my area. Now, if they wanted us to find the width, this is an example where they would ask us for that. So they give us the length of our rectangle and they gave us the area. They want us to find the width. So if area equals length times width, in order to get width, I'm going to do area divided by length, and that'll allow me to get my width. So my area was 24x3y6z squared over 4x squared yz5. So when I divide my coefficients, I actually divide those. 24 divided by 4 is 6. x3 divided by x2, I subtract the exponents to get x1. Positive exponents, I stay on the top of my fraction. y6 divided by y1 gives me y5. z2 divided by z5, 2 minus 5 is negative 3. So that means z3 needs to go on the bottom half of my fraction. And this right here is my answer for my area. For my width. So that right there was a review of what we did last week applied to area problems. Now let's get into what we're talking about today. So what you want to do is pause the video, go type each of these into your calculator and see what you get. All right, so when you type 2 to the 0 in, you should have got 1. 10 to the 0 is 1. 1500 to the 0, 1. Negative 206 to the 0. Probably got negative 1. All right. So what would x0 end up equaling is my question. Well, x to the 0 power would end up equaling 1. Here's the thing, guys. Anything to the 0 power is always going to equal 1. All right. The reason why that negative 206 to the 0 power is negative 1 is because our calculator is doing this to the 0 power. So whatever is to the 0 power always equals 1. So that's the first rule that you want to write down. For 0 exponents, always anything raised to the 0 power is equal to 1. So let's use some examples, do some examples that have x to the 0 power in them. So on number 1, I have x4, x0, x3 times x. This right here is just basic multiplying like we did back when we first learned our product rule. We just add up our exponents. 4 plus 0 plus 3 plus 1. 4 plus 0 is 4, plus 3 is 7, plus 1 is 8. Number 2, I see division. So that means I divide my coefficients and subtract the exponents. 4 divided by 6 is 2/3. 3 minus 2 is x1. And y divided by y, those cancel out to give me just 2/3 x. Number 3, I see everything is in parentheses and everything is to the 0 power. So I don't even need to simplify anything. As soon as I see everything is to the 0 power, my answer is 1. All right, so pause the video, take a look at these tables. What do you notice is happening on both of these tables? All right, so as I take a look at these, this is actually something that we've already kind of started talking about last week when we talked about dividing and subtracting our exponents. X to the third gives us 3x's. X to the 2 gives us 2. X gives us x. X to the 0 gives us 1. We just talked about that in our notes. But x to the negative 1, we talked about that on Friday. Whenever we have a negative exponent, it brings us to the bottom of our fraction. Notice x to the negative 2 has 2 x's on the bottom. X to the negative 3 has 3 x's on the bottom. However, when I go over to the other table here, 1 over 3 squared, 3 to the third power, that gives me 1 over 27. 1 over 3 squared, 1 over 9. So everything stays the same in the same location as I keep going until I get to 1 over 3 to the negative 1. Notice that my 3 to the negative 1 now moves up on these 3. So whenever I have a negative exponent and it's in the denominator, I have to move it up in order to change it to a positive exponent. We never want to keep negative exponents in our final answer. All right, so here's our negative exponents rule. Whenever we have a negative exponent, we're going to move it down, but if it's already down, we're going to move it up. So if it's not in the denominator, you put it in the denominator and it becomes a positive. If it's already in the denominator, you're going to move it to the numerator, and then it'll become positive. Here's the thing, negative exponents are unhappy. That's an easy way to think about it. To make them happy, they have to cross the division line. So one suggestion that I have for you guys is when you guys have negative exponents, circle their base and that exponent and point out where it's going. So like here on number 1, I have k to the negative 4. I'm going to circle it and draw an arrow telling me, hey, I need to move it to the bottom. So then what happens is on the bottom now, I'm still going to have 5, but now I have k to the 4th power. 1 is all I have left on top. And that's my final answer. Excuse me, sorry about that. So now let's try number 2. Let's do the same thing. Circle your negative exponents, move it to the bottom. Circle your negative exponent. That one, on the other hand, moves to the top. So now, on top, you have still C2, but now D5 is also on top. On the bottom, though, your B negative 3 moved down. So now I have B3 on the bottom. Nothing needs to simplify, so that's my final answer. So now let's try number 3. On number 3, I have negative exponents. I also see a negative coefficient. We talked a little bit on Friday that when we said we had negative coefficients, those don't move. All we do is simplify those like we normally do. So negative 3 divided by 21, that is negative 1 over 7. My A4 is going to move down because it's a negative. So I'm still going to have A2 at the bottom, but now I also have A4. This B7 on top stays where it's at. The B7 on the bottom stays where it's at. The C negative 5, though, needs to move up because it is a negative. So let's move it up to make it a positive. So at this point, now I need to look to see, does anything simplify? Do I have more than one letter? Well, I have multiple A's on the bottom. So A2 plus A4 gives me A6 on the bottom. B7 and B7, I see it both on top and the bottom. They cancel out, so I don't have any more B's. My C's I don't have multiple of, so that's going to stay on top. And I can leave this as like with the -1 on top as well. All right, I will do one more and that'll be the end of this video. So number 4, I'm gonna go ahead and move my negatives first. So I have x4 over 5 times 10 y5 over x6. On top, I now have 10 y5 x4 over 5 x6. That simplifies to 2 y5 over x2. Last one, number 5. Here's just one more. B7, C5, A4. On top here, I'll have A5, and I will have C5. On the bottom, I will have 10, A2, B7, and another B7, all times 5 over A4, C15. So on top, I'm going to have 5, A5, C5. On the bottom, I'm going to have 10, A6, B14, and C15, which then simplifies to 1 over 2. A1 goes on the bottom, B14 is on the bottom, and C10 is on the bottom. And that's my final answer.